Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to discuss about inverse discrete Fourier transform using DIT algorithms. So we already discussed the discrete Fourier transform. So now we are going to discuss about inverse of that particular operation. That is inverse of discrete Fourier transform. So we are going to use this decimation n-time algorithm. We are taking a problem 4-point input. Look at the problem. So find Idft of the sequence x of k equal to 2, 3 plus j, minus 4, 3 minus j. So this is the actual given inputs. So number of samples will be 4. Capital N equal to 4. So 2 is one sample, 3 plus j is one other sample, minus 4 is another sample, and 3 minus j is another sample. So this is the 4 samples. Now we are going to use this as a DIT algorithm, decimation in time algorithm. For decimation in time algorithm, input is bit reversal, output is natural order. Again, we are performing an inverse discrete Fourier transform. So for an inverse discrete Fourier transform, so the input should be fed as a complex conjugate, and then output also we need to take a complex conjugate, and then we should divide by capital N. So here n is number of samples is 4. So we are taking as a 4. So final output we should divide all the values by 4, and input also fed as a complex conjugate, and output also taken as a complex conjugate. So complex conjugate is very simple. Real part no sign is changes. Imaginary part sign should be changed as a, if it is a plus it should be changed to minus. If it is a minus it should be changed to plus. Look at this actual inputs. So here is 2. This is 3 plus j, and this is minus 4, and this is 3 minus j. So for 2 and 4, if you take a complex conjugate, no changes because there is no imaginary part available. But look at these two inputs, 3 plus j and 3 minus j. So if you take a complex conjugate for this, so 3 plus j, if you take a complex conjugate, it becomes 3 minus j. Similarly, this 3 minus j, if you take a complex conjugate, it becomes a 3 plus j. So instead of 3 plus j, we need to use as a complex conjugate of 3 plus j. Instead of 3 minus j, we need to take a complex conjugate of 3 minus j. Look at this. This is x star of 0. This is a complex conjugate of values. So this star indicates a complex conjugate. So x star of 0. This is a complex conjugate of x of 0, complex conjugate of x of 2, complex conjugate of x of 1, and this is complex conjugate of x of 3. Look at this x of 0. So this is 2. If you take a complex conjugate, again it gives the same 2. So x star of 0, that is a complex conjugate, x of 0 will be equal to 2 only. Now look at this 2 value. This is an 0, 1, and this is 2 value. 2 value is minus 4. Even if you take a complex conjugate, no changes. So x star of 2 also equal to minus 4. Now look at this x star of 1. This is a complex conjugate of x of 1. So x of 1 is a 3 plus j. If you take a complex conjugate for this x plus j, it becomes x minus 3 minus j. Look at this. So x star of 1, that will be equal to 3 minus j. Now look at this x of 3. So this is 3 minus j. If you take a complex conjugate for this, it becomes 3 plus j. So x star of 3, that will be equal to 3 plus j. There is a complex conjugate of third sample. Now look at this twiddle factor. First stage both twiddle factors will be 1 only. So just we multiply with this twiddle factor, and that should be added for this leaf and subtracted for this leaf. Look at this. So first input is 2 and another input is minus 4. So just add for up leaf to 2 plus minus 4, that will be equal to minus 2. And then down leaf, first we need to subtract it and multiply with it, the twiddle factor. So twiddle factor is 1. If you multiply anything with 1, there is no changes. So that is minus 4 into 1 will be equal to minus 4 only. So 2 minus minus 4, that will be equal to minus of minus 4 becomes an plus 4. So 2 plus 4 will be equal to 6. This is first butterfly. Now come for a second butterfly. So we have one input is 3 minus j and another input is 3 plus j. So first take this 3 plus j, multiply with the twiddle factor 1. So 1 into 3 plus j will be equal to 3 plus j only. So just add the value for up leaf and subtract for a down leaf. So 3 minus j, this is an one input, we take directly. So 3 minus j plus another input is 3 plus j into 1, that is also 3 plus j only. So 3 minus j plus 3 plus j. So minus j plus j cancels. So 3 plus 3 becomes 6. Now come for a down leaf. Instead of addition, we need to perform subtraction. So 3 minus j minus 3 plus j. So if you multiply inside it, it becomes minus 3 minus j. So minus 3 plus 3 will be cancelled, minus j, here also minus j, we get a minus 2j. So here minus 2j. So this is the first stage output, minus 2, 6, 6 and minus 2j. Now we can go for a second stage. Second stage, look at this. This is one input and this is another input and total factor is 1 and another butterfly. So this is one input and this is another input and total factor is minus j. Now we can take this first butterfly. So we have one input as in, here look at this. So one input as minus 2. So we take this minus 2 plus another input is 6. So 6 into 1 will be 6 only. So plus 6. So minus 2 plus 6, that will be becomes a 4. And down leaf, look at this. So we have a minus 2 minus of 6. So that will be equal to minus 2 minus 6, that will be equal to minus 8. Now come for a second butterfly. One input is here and this is another input. So we take this as a 6 plus, we have a total factor as a minus j. So input is minus 2j and total factor is minus j. So now we need to multiply these two and that should be added for this leaf and subtracted for this leaf. Look at this. 6 plus minus 2j into minus j. So minus into minus now becomes plus. And then 2j into j. J into j will be j square. So j square will be equal to minus. That is minus 1. So total answer will be minus 2. So 6 and this will be minus 2. So 6 minus 2 will be equal to 4 here. And come for a down leaf. So instead of plus, we need to put it as a minus. So 6 minus minus 2j into minus j. So now minus 2 into minus becomes a plus. J into j, so j square, that is also becomes minus. This minus and this minus becomes plus. So we get a 6 plus 2, that is equal to 8. So final output, look at this. You have a 4, 4, minus 8 and this is 8. All the values are real part. So if you take a complex conjugate, no result will be changes. So look at this. We get a 4 here 4 and this is minus 8 and this is plus 8. Only thing, we need to divide by 4. Because there is no complex parts. So only real part is available. So 4 by 4 will be equal to 1. This 4 by 4 will be equal to 1. And minus 8 by 4 will be equal to minus 2. And 8 by 4 will be equal to 2. So this is 1, 1, minus 2 and 2. Thank you.